Yeah. Hi. So all the code is on GitHub. You don't need to write things down or take photos or whatnot. Everything's there. So you're on that path. You know, you see, you want to get. Everybody says that you need to have 100% test coverage, and you're working on that path. And then after months, weeks, or years, you reach that summit, and then what? What happens then? So I've had this happen to me already 4 or 5 years ago when we transferred our company from a consulting company into basically developing our own products. On the 1st of January 2014, I sent all of our clients, some of you in this room, an email like, sorry, no consulting anymore from us. We're going to be doing our things, like our own products and from now on. And that kind of put me as a CTO in a position where I made the requirements all of a sudden. And one of the requirements were I want to have 100% test coverage on everything we do. And that was one of the best decisions. And today, when I have to work with code base that does not have that, it feels icky. Because when I change things, I'm like, how do I know this works? Like that said, 100% test coverage does not give you bug-free code, but it's still better than 60 or 70%. So how many of you have at least some of the packages tested, covered 100%? Oh, okay. Good, good, good. What do you do when you get to that? You have this huge test suite, then you actually start to remove tests. So how does that work? You still keep the test coverage, but you actually start removing the tests because the more tests you have, the slower they're going to be to run and more annoying they're going to be to run. Your developers are not going to run them because if the test suite takes 20 minutes, who cares? I'm just going to commit and push. Your builds are going to be faster, so your deploys are going to be faster, and it's going to be way faster to refactor code because if you change just this tiny part of your app, and then you have to fix 37 tests, every refactoring is painful, and you then don't do them. And if you don't do refactors after 2 or 3 years, you're in a huge amount of technical debt, and you're feeling the pain. So take a katana, slice it up. Before we begin, who knows what's this? It's a, yes. How many colors you could order your Model T in? Any one, as long as it's black. So there's a great Python package now available called Black. It has 0 configuration options, and basically it formats your code into some way. And since adopting Black half a year ago, my life has improved so much that I just want everybody to start using it. It does not allow you to configure anything. It just basically say, yeah, this is how our code is going to look now, and I don't care how it's going to look. Mostly true, yeah. I know, mostly true. And I actually went back and looked at our pull request like a year ago, and I think like 30 to 50 comments on every percent of the comments on pull requests were about styling, and they disappeared. So it's just amazing. And you're going to see I'm going to use it. I'm going to use it now. You're going to see things moving around. So that's all Black. Enough about talking. Show me the code. Oh, yeah. I have to go into. Come on. Minimize this one. And okay. So what we're going to do now is we're going to have a very simple script that just prints something to the console in either in one of the colors that you want to print in. So roses are red. This is a hack, and we have tests. Let's confirm that the tests pass. Okay, so 2 passed. We're gonna open the test coverage. 100% test coverage. Woo! Right? And then we run the thing, and roses are red. This is a blah, blah. Why is this not black? I have 100% test coverage. Why do I have a bug? This is not fair. Well, if, let's, so what we're going to do now is we're going to add another flag to the testing command, which is cough branch. What this does is it tests also that you've covered all the code branches in your code base, all the if statements. And if you run it again, you see now we're at 93%. Our code is actually not entirely tested. And there's a new thing here said that line 4 didn't jump to line 7 because the condition line 4 was never false. And if we look at the test, that's true. We test for red, we test for blue, but we don't test for anything else. So this is a small thing that you could do to improve your basically so your test coverage reports is just to add to set it up in a way that it also reports on branches. And now that we know that, we can add this exception, and we can also now test the black, so some other color that is not defined up here. Let's see if we're, yep, back up to 100%. And now if I run it, we at least get like an expected failure. So the most annoying bugs are when things just kind of seem to work, but not really. Here you at least know, like, well, there's, like, I know where to start debugging this. It's still a lot of code and a lot of tests for such a simple thing. Can we improve it? Okay, so let's look at the diff between the previous thing and the new thing. So we removed all of these ifs, and we removed a bunch of code, and we just added an enumerator, and we have just one test instead of 4 tests. Sorry, 2 tests. So what changed? Instead of having in here, instead of having a big if saying like if red do this, if blue do this, if black do this, you define an enumeration and say like these are the colors that we support. Like red is this, blue is this, and then you say here in your method that like this color parameter needs to come from this enumeration, and this then allows you to not do any of the checks in your code or in your tests, but use MyPy for that. So if I now do this, it's going to tell me that this color enumeration has no attribute black, and this is here, right? So anywhere in the code we would call this method and give it something that does not exist. MyPy will report on that. So MyPy is a static type analysis tool for Python that was inspired by all these latest developments in the functional programming space from Haskell and languages like that. And I've had the privilege to work with Dom on this summer, and he's a full-time Haskell developer. I dragged him back into Python for three months, and he really inspired a lot of the packages that we're publishing these days, also for Pyramid. And I also started looking into Elm, which is a fantastically designed front-end language that is functional and statically typed. And now my code started changing. So if you look at, like, this is now 15 lines of code compared to the previous over 40 lines of code, and it has way more guarantees that it's going to work as one would expect it to. So I really think that like we should start using enumerators more, and we'll come back to them. So if we now fix this to blue, for example, yay. Discard. Any questions at this point? Yes?
One important. NumPy and code annotations like that are available from Python 3.5 up how to do that, as we are still in some way stick to support 2.7.
Okay, so one of the biggest developers of for organizations driving development behind MyPy is Dropbox, and they're still on 2.7. So everything works on 2.7, just with comments instead of like in syntax. You just write comments next to the code, so it works. And also Dropbox.
Dropbox is on Python 3 now.
Yeah, the point stands. Yeah, and they also they actually developed a tool where you run like a wrapper around your application in production, and it will record what kind of data is actually getting sent around your code base, and then basically you can also say and then store that information. You can download it and then apply it to your code base, and they use that to cover. I think they have like all of their code base now covered with types, and they did it in a couple of weeks with that tool, and they have 1.5 million lines of code. So it's not something that you have to do manually. You can actually record production data and then just inject the types into comments. Okay. Who's using Flake 8? Awesome, everyone. I'm just going to go quickly through a couple of Flake 8 plugins. So again, a very simple method that gets you max values from a list. And here's the test. Obviously, like from here you would get a 5. From here you would get a 7. But then there's some strange error. List objects not callable. If I would run Flake8 before that, I would get that list is used as an argument and basically shadows the Python built-in, and maybe you should consider renaming, and that gives me the idea that like this here just won't work. So again, inspired from what Haskell and Elm are doing, there are things that a computer can prevent us from, like bugs that computer can prevent us from doing, from writing, and computers are really good at that, and so let's use computers to do that. Use as many checks as viable for your use case, and don't rely on your mental power to always recognize all the little nasty bugs. There's Flake8 has a number of plugins. You should definitely look into them. And there's another one here, basically, yeah, a class with some stupid names, and then we just test that these two parameters are of the same length. And I get this strange error where how there's one is 29, one is 1, but how it, what? This is the same amount of text. Ah, there's a comma here. Who had this happen to him or her? Yeah. Stupid commas, invisible commas at the end. And again, if you would run Flake8, you would see that at line 23, well, sorry, no, line 23, line 5, you would get notified. Or if you just use black, when you save it, you're going to get parentheses around this text, and you're going to be what? Oh, now I see. Done. So use black. Okay, we don't need this anymore. Okay, any reasonably sized test suite has a lot of mocks. And I review a lot of code, and I see people abusing mocks a lot, so I'm going to go through a couple of use cases of how not to abuse mocks. Very simple function to get the current microseconds, and then how we test it. So let's see that the test runs. It does. So what we do is we patch this datetime object, and then we say if now parenthesis is called, and then like dot microsecond return 999, and then we assert that this method returns 999, and it does because we mocked it. Everything's fine. But then a week later, we add another function that gets the yesterday's microsecond, and now we also need time delta. So instead of from datetime import datetime, we just import datetime and then use datetime, and datetime time delta. And it's the same, like nothing changed except we added this one function here and changed the import. But the test now breaks, and it breaks in a really bad way. So it's assert, magic, mock, whatever. This is a really prime example of a really bad test, because you basically didn't change anything and the test broke. And imagine this code base would be, several 100,000 lines of code, and it would probably 37 tests would fail in a similar way, and you would just spend an hour fixing it for a very simple refactor. So what to do? And why the test failed was because we're still patching the datetime object, but now we're patching this object, so this would actually have to be like this, right? But you have to find it, and you have to know how to do it better. Anyone uses freeze gun? All right, cool. So not everyone. Freeze gun is a fantastic package to basically allow your test to travel in time and remove mocks from your test code. So if we go back to our test code, instead of mocking and then mocking the actual calls that your functions are doing, you just basically say, in this method, this is the time. Anytime, any code that uses get now, that is going to be the return value, and and then just assert. And let's see if this works. Okay, and so even if we now do like this, and we change these imports back to what they were, this is still going to work. And even if we would do like UTC now or whatever, that would still work. Because we're not mocking the actual internal calls in this function, but we're mocking the value that the Python gets from the time libraries. Super useful. Any questions at this point? Yes?
So that particular pattern often bites me when people do module level functions that they get exported from other modules. Do you have any patterns to get around that?
No, not really. I mean, then you have to then do like content managers inside the test, not the entire test function, but just like certain lines of code, or rewrite that underlying code that smells.
Do you have any patterns for, instead of having module level functions, for writing that kind of utility in a way that is easy to mock without causing these problems down the line?
Not from the top of my head. Yeah. If you give me an example, maybe I come up with something, but. A similar thing that is abused all the time is mocking logs. So here we have a function that processes something, and it prints into logs, and we want to make sure that this prints makes sense, so that because this is what the user sees, and it's really nice to have in tests like all the logs printed, so you can visualize how the output will look like. And again, we patch this object, and then we say, was it called 2 times? Yes, it was. And what was the first call? Sorry. And what was the second call? Let's see if it runs. Cool. But then we just change, because product owner wanted this to be a warning, so it's more visible, instead of an info. And we run the tests because we want to see what broke, and we get this. Everything explodes because we're like, again, the calls are a bit different. So how we can improve this is by using the lock capture from the test fixtures library. So this is for PyTest. I know for a fact that something like this exists for Zope test runner. I'm just not sure what the name is, but it exists. I've used it in the past. And what you do is basically you capture the log, and then you just say, do logs look like this? sure they are. And now even if I do this, the error is much better. So this was expected. This was actual. You immediately see what the difference is. You're much faster to fix the test. Again, like this it might sound trivial in a 25 lines of code, but when this logs span hundreds and hundreds of lines in a back-end processing task, it's really useful if you have error reports that actually help you instead of confuse you. Okay, another from the Flake, another Flake plugin. I've seen this happen too, when people use just assert true, assert true, assert true, assert true, and then an expression. And again, this will run just fine. You say, yeah, we have everything's covered. Then you change something here. I just like super trivial. I change this from 1 to 2, and then I want to see what broke. And false is not true. False is not true. False is not true. Like all the failures are the same, which there are failures, so you know where to start, but it's not as good as it could be. Again, if you would run Flake beforehand, it will tell you that it's instead of doing equal comparison, it's better to use assert equal because the error message is going to be better. Let's look at those. And also, instead of true is not false, or yeah, whatever the error message was, like these error messages are way better. So 2 not less than 2, 2 not found in 0, 1, and 2 equals 2, and it shouldn't equal. We can be better though, more Pythonic, especially if you're using PyTest. Yay! Only one person in the room. There's 2 of us. So instead of having a class that inherits from unit test and then have this self-assert Java style asserts, you just write Python, and this will actually also generate nice nice error messages, like so. So 2 less than 2, where like 2 was this, and then this was the function that we called, and again, here was the result, and then here. So yeah, use more. It's always good to use a more specific assert than a less specific assert, because when things go wrong, the developer that's going to look at that code, probably you 3 months down the road when you don't remember why you wrote something and you're bitching about it, and then you go git blame and do, oops, that was me. Use specific asserts. And there's another plugin called Bugbear that helps you prevent all sorts of nasty bugs that we're aware of. So this will increment a number by 1, and then this will append to a list. We have 2 tests to confirm it. Run the tests, and they break. Because this in Python is actually something like this and doesn't really do anything. And this is a known Python gotcha where you shouldn't use mutable default arguments because they get used over and over again. And you don't get a new list every time you call a method, just on the first time the method is instantiated, called. And again, if you would run Flake 8 on this code before you start writing tests or running it in production, you would get that Python does not support this, and you shouldn't use mutable data structures. Sure, a lot of people know this, but maybe someone in your team does not, and then you're going to have to catch this in your code review, and maybe you won't catch it. Why risk it if it's like a couple of milliseconds for your computer or the CI system to catch it? Ooh, another one where everyone gets stuck with mocks. Reload. So we're doing we want to see how Yen did last month, so we do a request for the 1st of October and the last of October, and then we return the 1st of month and last of month value and print it out, and we have a test that confirms that. Cool. So what we did here is we mocked the requests, so this object here, and we say when you have request.get dot parenthesis something in those parentheses dot JSON dot parenthesis return this thing. And here we're lazy, and we're just mocking it once and say for every get request return the same value, because this is simple code, we don't need to complicate, and it's the same value, but you know, it doesn't matter. You could actually do it so that it would return different values based on what was passed into the get method, but you would need to use side effects, and you know, if you haven't worked with side effects before with mock, good luck figuring it out. So this is 100% test covered, everything's fine. Let's see how we can do it better. The code here is exactly the same. What changed was we started using responses, which is from the same author that wrote requests. Who uses responses? Cool, people are going to learn. So you say there's going to be a get request to exactly this URL, and please return that. And there's going to be another get request to this exact URL. You see there's a different date here, and please return that. And then you just specify what kind of the requests they're going to be and what the return value should be, so you can really nicely mock the network input-output. And we run the test, and it fails. 1, 1, 1, 2. And it fails because here we said response and response to, but here we didn't. Good luck catching that. You know, it was perfectly, the previous code was 100% test covered, still a really nasty bug in there. So it's 100% test coverage is not everything. Your tests need to be good. I think that's the last one. Yes. So we have a method to basically describe a car. So this car has X wheels and Y doors. And we have a test to describe it. So we give it a dictionary. This car has 4 wheels and 5 doors. And we also check for bad parameters, because we're not using enumerations here, because it's more of a complex data structure. And we assert that if we don't give it wheels and if we don't give it doors, this function will complain, because we need it to complain so that the error message is descriptive to the user or to developer, so they know what they did wrong. We run it. 100% test coverage. Do I get a yay? Everyone expects. Everyone knows what's gonna happen next. Boom. As a string object has no attribute keys. What? And then you're digging through the code, and you realize you put here with a parenthesis. It's, I mean, sure you're gonna catch it, but the computer would catch this in an instant. So save time. Be lazy. Oh, I have changes. Okay, so how to do this better is the same similar principle to enumerations, which are basically key value list of key values, and then you can use a name tuple, which kind of constructs a very simple object that you say it has, it can has only this parameters, and you say again for this describe car method, the parameter needs to be of this type. And we can again run the tests. Everything's covered. But now we run MyPy before we're running the code, and we see that the argument 1 to describe car has incompatible type, string, expected car. You go here, and then we see that we actually passed in string instead of car. So this is what I said before, like, the computer caught this in an instant, and you just basically need to be specific, like what are you expecting, what do you expecting this car parameter to be, and again we don't need we don't need the whole if structure here to check if certain parameters exist or not, and we don't need tests for that because using name tuple already gives us guarantees that the object that was constructed and sent to this method has all the parameters that we need. Yes. And going further with that, you also have, especially so name tuples have been around since Python 2.5 or something, at least as an add-on package. And you also have, now in Python 3.6, I think, or 3.7, you have data classes, which are name tuples. So if you go from enumerations to name tuples, the data classes are then the next thing. I'm going to showcase data classes possibly tomorrow on a lightning talk about how to do REST APIs with Pyramid, and I'm going to use data classes there. Basically, with a data class, you can also create like functions, methods for that objects, and they have really good support for the static type analysis built in. So look into those. Is this it? Demo end. We've done. Okay. Recap. Use black. A lot of the issues that we pointed out today would come up in your editor because when you hit save, your code was going to go like whoop, and then you're like, whoa, something strange happening. What am I doing? Or you're just writing things down. Like using black feels like you're a mad scientist, and then you have this butler cleaning up after you. You don't like I don't remember even today like how we're supposed to format things. I just like save, whoop, everything is nicely in place, done. So it's like takes the mental burden off of that. And so like if you're writing something and code does not get thrown around, that's also like a signal that my code is not good. Something should have happened there and didn't happen. Freeze gun and log capture and responses are fantastic tools to make your mocked code much more readable, much more robust. And then just go on PyPI, type in, search for Flake8, and then there's, I think, over 100 plugins, and a lot of those are not usable. But still, maybe every week or every month, take one or two and put it into your build process, and your code is going to get better and better all the time. And it's not that you're just improving code, you're making sure that you're not degrading the new code that's coming in. And then really look into think about how to use enumerations, name tuples, and data classes along with MyPy. And to do that, I strongly recommend going to this talk that's going to happen on Friday. Elm is, like I said, a fantastically designed language for the front end. It has all this functional programming, static type analysis built in, and I've started looking into Elm in the summer, and I don't think I wrote more than 100 lines of Elm to date, but it's still completely transformed how I think about writing code in Python, because it gives you that idea that you need to take care of you need to think how the data will look in your code, and then you describe it, and then you have all these guarantees that I've shown you, and just going to a talk and thinking about the ideas that how these functional programming languages how they are designed is going to improve your code writing abilities. Shameless plug, we're hiring. That's it. Questions, please.
What was that cool Git demo thing you used?
Oh, so if you go to here,
Yeah.
README, there's an alias and how to do that.
So checks like running MyPy, running Plate8, what would you recommend for when to do that? Do you do it in CI? Do you do it pre-commit? Do you do
Yep.
it on stage? All of the above?
Yeah, we use Niteo. We use pre-commit, and pre-commit works in two stages. You have the commit stage and the push stage. And on the commit stage, you can say like on commit stage, just run this couple of checks that are really fast, and only run them on the diff, on the things files that you changed. And on the push stage, when you're actually ready to push, run everything and run on all the files.
How do you set up that for every repo start?
There's a .precommit CFG files. It's precommit is a library to do that.
Okay.
I have it, Lane.
Every repository that you have, it's just one file to add.
No, that's not it.
The theme.
Yeah, man, that was a config. So you say isort, you say flake8. I want to run pip run flake. And so this would run on every commit. This would run on every commit because it's fast. So check merge conflicts is slow, so I just run it on push. Yeah, this works really. Like pre-commit is a fantastic tool.
And you usually add just as a requirements dev or something like that?
Well, it installs itself in into Git hook.
Okay, but okay, you don't have that on that package right now. So what do I do? I basically add that with pig install or
Yeah, let me verify that. Can we shut down the camera?
With Glue. Glue can install.
Glue?
Yeah, or you package.
I think we have it here. Yeah, it's a Python package. Just do this, and then I'm not sure this is gonna run now, but we can try. So yeah, it's running isort. I think my environment is out of date. No, it's not. And then it's running flake8. And then it's trimming trading space, and then it's fixing end of file so you don't have end lines, and it's checking for merge conflicts so you don't accidentally push garbage. We do spec challenging in our code base because my eyes hurt when I see typos. And that's it. So you see, and it's 30,000 lines of code, and it's pretty fast. More questions? Okay. Thank you.